All right, this is section 6.1 on roots and radical expressions. Hopefully, this section will show you how exponents and square roots or cube roots or fourth roots go hand in hand. Okay, so to start out with, I have 5 squared equals 25. Well, what that means is that 5 is a square root of 25. Okay, and here where I have 5 cubed equals 125, that means that 5 is a cube root of 125. 5 to the 4th power equals 625 means that 5 is a 4th root of 625. And to follow that up, 5 to the 5th equals 3,125 means that 5 is a 5th root of 3,125. Okay? And to put that in more general terms, in your textbook there is a box on page 361 talking about the nth root. It says if a to the nth power equals b, then a is an nth root of b. Okay, and here is how you write the nth root of b. So now we need to talk about the parts of this. Right here, this, let me get a highlighter. This symbol here, that is your radical. Okay, your radical symbol, your radical sign, whichever one you want to call it, does not matter. This little number that's right here, that is called your index. Now, if there is not a number written right here, it is understood to be a 2. Okay? No number here means square root. And then finally, the number that's underneath your radical symbol, that is your radicand. So now that we know what this symbol looks like and what all of the parts mean, let's go back up here and rewrite these in radical form. Okay? When I say that 5 is a square root of 25, here's the way we write that. 5 is a square root of 25. Here where I have 5 is a cube root of 125. You write 5 is, here's my radical symbol. I put a little 3 floating inside that little check mark part to show that it is a cube root, and my radicand is 125. Next, 5 is a 4th root of 625. So 5 is, that's 5 equals once again, and now I have to do a 4th root, and my radicand is 625. And then for this last one, 5 is a 5th root of 3,125. Okay, just so you get used to seeing it written in radical form. So now, let's go down here to the bottom of this page. Okay, there's a couple of things that you need to know. Okay, if n, your index, is an odd number, that means that there is only one real root. Then if n is even, so if this index is an even number and your radicand is positive, that means you have two real roots. One of them will be positive, one will be negative. However, if your index is even and this is a negative number underneath, so b is negative, that means you have 0 real roots. So now let's go back to this odd one here for just a second. Okay? So if this is odd, I don't care if this is a positive number or a negative number. I'm going to get one real root. So here's the deal with that. If b is positive, then the root is positive. However, if b is negative, then your root will also be negative. All right, so we're going to look at an example and answer some questions about it. Okay, we start out, our example is the square root of 9. Okay? A couple things just to get you used to the different terminologies that we're looking at. First thing I want to know is, what is the index? Well, remember, there's not anything written in that little check mark part. There's not an index given. So just a minute ago, I told you if there's not a number where the index belongs, it is a 2. That means it is a square root. Okay, so is the index even or odd? Well, 2 is an even number. And is the radicand positive or negative? Well, my radicand is 9, which is a positive number. And then I want to know how many real roots will I have? Well, I have an even index and a positive radicand, so I will have 2 real roots. And what sign will the roots have? Well, one of them will be positive, one of them will be negative. So now, we know that, the square root of 9 is 3. If you type it in on your calculator, that's what it gives you. But now, we are supposed to have 2 real roots, plus or minus. So technically, the square root of 9 is positive 3 and negative 3. So why does your calculator only give you the positive 3? That's because it is the principal root. Okay, I'm going to give you a definition for the principal root, and then we're going to make it real simple. Okay, principal root is technically the non-negative root. Okay, and non-negative means it can't be negative. It could be positive or it could be neutral. So technically, your principal root would be 0 or a positive number. Okay? And to make it even simpler than that, the principal root is what the calculator gives you. All right, so 2 more examples here real quick. Why don't you go ahead and pause the video and see if you can answer these questions and actually find the roots. And then when you're done, unpause it and come back here. All right, for the first one, there is no index written, so it is a 2, meaning it's a square root. That is an even index. The radicand, the 16 underneath, is positive. That means I will have, with an even index and a positive radicand, I'm going to have two real roots. One of them will be positive, one of them will be negative. For the other one, the square root of negative 25. Well, there is no index given, so it is understood to be a 2. It's a square root. The 2 index is even. The radicand underneath my radical, that is a negative number. So when I have an even index and a negative radicand, I'm going to have 0 real roots. And what sign will the roots have? Well, since I'm not going to have any roots, that is not applicable. All right, problem 1. Part A, I've actually got 3 parts for part A. It asks what are the real cube roots of 0.008, negative 1,000, and 1 over 27. So here, I'm going to write it in radical form. I'm looking for a cube root of 0.008. And you can type this one in on your calculator. But I think what might be easier is to write it in fraction form, so that I've got the cube root, that is 8 thousandths. So it's going to be 8 over 1,000. And then you just take the cube root of the top and the cube root of the bottom. So the cube root of 8 is 2. The cube root of 1,000 is 10, which in decimal form, that is 0.2. So that is the cube root of 0.008. For the cube root of negative 1,000, I've got a cube root, and negative 1,000 is my radicand. Now, a lot of times people automatically look at this and see a negative underneath and say, oh, we can't do that. Well, you can, because it is an odd index. So I know that an odd index and a negative radicand is going to give me a negative answer. And then I don't worry about the negative anymore. I'm just going to take the cube root of 1,000, which is 10. And then for this last one over here, I have the cube root of 1 over 27. And again, we're just going to take the cube root of the top and the cube root of the bottom. So the cube root of 1 is 1. The cube root of 27 is 3. All right, so then the next one asks, and my page isn't formatted quite right, so it's split onto 2 pages, but I want to know the real fourth roots of a couple of things. Okay, so when I want the fourth roots of each of these, let's write it in radical form first. This would be the fourth root of 1. Going to be the fourth root of negative 0.001. And finally, I have the fourth root of 16 over 81. So now, the fourth root of 1, that just means what do you multiply by itself 4 times to get 1? That answer is 1. And technically, you know, it would be plus or minus because this is an even index. So plus or minus 1. For the next one, this is an even index and a negative underneath, a negative radicand. That means there are no real roots. And for the last one over here, it's the fourth root of 16 over 81. We're just going to take the fourth root of the top and the fourth root of the bottom. So, to find the fourth root of 16, what do you multiply by itself 4 times to get 16? That would be 2. And the fourth root of 81, what do you multiply by itself 4 times to get 81? And that would be 3. And this is plus or minus. Because my index was even, I should have 2 real roots for this last one. Same as that first one over there. All right, before we go on with the rest of the notes here, I'm going to give you a list of things to the second power, third, fourth, and fifth, maybe even a couple to the sixth power. So I'm going to end this video. We'll do just a video on those, and then we'll come back to the rest of the notes.